Good morning, everyone, and thank you, Christine, for the introduction. I'm very excited to welcome you all to this workshop on science communication through the effective data visualization. As the title also specified, today we will be discussing some strategies for preparing high-quality figures for journal publications. I want to talk about a little bit on why I am here today to talk about this topic. It's mainly because even though I don't have a lot of publications, but I do help the process of producing figures for either independently or collaborated with other professors and students, which means I actually spend like many hours creating and refining figures for publications. And I have also learned some lessons along the way. So today I want to walk you through my workflow of the entire process of publication with a specific focus on the figures. I will also share some struggles I had and all the tips and tricks to deal with those struggles, as well as the lesson I learned during this process. So now let's take a look at the agenda for today's workshop. We will have 4 main topics to cover. Firstly, I want to emphasize the importance of figures in journal publications. We will discuss why it is crucial to invest your time and effort in creating the high-quality figures. Next, I will introduce the 4 principles of good visualizations and explore how they can be applied to figures specifically for journal publications. Then I will introduce the 6 essential steps and explain how to prepare for each of them. Along the way, I will also share my past experiences and tips in preparing each of the steps. Finally, if we have enough time, I will demonstrate a case example of a published figure in R. Other than the final case example, during this workshop, I will also provide some tips because I'm mainly using R to produce those figures. So some of the tips are only applicable to specifically in R, but the principles and the techniques discussed in this workshop are also applicable to other software. All right, let's dive into the importance of the figures in journal publications. Why good figures matter? So figures can have a significant impact on how your research is received and understood by others. And here are some key reasons, I think, why the figures are essential. Firstly, figures can enhance the reproducibility and transparency. It means that by providing a clear and detailed visual representation of the data, methods, and the results of your research, you can make it easier for others to reproduce your work and verify your findings. Secondly, figures can make information more compact. That means figure can have a higher information density than the text or tables, which make them a valuable tool for summarizing the large amount of data in a single visual. Thirdly, figures can improve readability. It means that the visual allows the author to convey a very complex concept or findings in a visual format, which is an effective way to communicate the content of your paper that may be difficult to explain in writings. Because the visualization just help to reduce the cognitive load to digesting information compared to purely just reading the text. Finally, figures can make a paper more engaging and memorable. Together with abstract and tables, figures are often the first items many readers of the academic articles will read to get a sense of the key results. So therefore, having a high quality figures can help your paper stand out and be more memorable for your readers. It's worth noting that there's an increasing number of scientific journals now feature the thumbnails of the figure alongside with the title and the summary sentences. For instance, this is the screenshot from the Nature Food Journal website, where you can see all the figures, all the papers are listed as this manner. They have the types of this article, and the title and the summary sentences, and here are all the thumbnails of each of the papers. As you can see, figures are really differentiating among papers and grab readers' attention. So in this example, this is one of the example in the Nature Food Journal as well. We can see the figure, and we can see one figure with some limited text, and not very, the figures are not very appealing. It may not catch your attention unless you're highly interested in this topic. This basically is a closer look at the figure. We can see there's a numerical order of the three variables that list here, and three kind of flat trend lines over the years. So really limited information we can get from this figure. In contrast, let's take a look at another example. Here is the title and the summary sentences, and this is the thumbnail they're using for this paper. Let's take a closer look at this picture as well. So here we can see there are multiple panels, except for panel A. The rest of the panels contains three lines in different colors, showing the fluctuation in different and over time, and the difference of the three lines vary in different panels as well. In the upper left corner, where we see the panel A, it accompanied with the bar charts and maps provide additional insight for those line charts, showing the total production in different countries and the graphical distribution of the included countries. So I think this type of visualization is much more engaging and insightful, make me more interested in reading these figures. So if you have time, feel free to go to any journal website where they provide the thumbnails, and you can test yourself if you will be attracting to those paper with higher quality of figures. This is just simple two examples. So another thing I want to also highlight is that it's not just the figures that showed up in the thumbnails. Journals are now also exploring the visual format of an abstract. As you can see, this is the two screenshot I have here from Bingjie and Elsevier. They have provided guidance on how to create a visual abstract. I won't dive into the details of them, but it's clear that the visualization are playing a vital role in scientific journal publications, whether it is a traditional figure or a multimedia element or a well-designed visualization can significantly enhance the impact and engagement of your research and make it more accessible to a wider audience. Now let's dive into the principles of visualizations. The principles are crucial for selecting the appropriate elements for your figures and help you to evaluate the quality of your visualizations. So the principles I'm introducing here include evidence, efficiency, emphasis, and ethics. This is a 4E principle which was developed by Dr. Elena Nomova. So you'll be familiar with the concept already if you have ever taken the data visualization and communication class provided here at our nutrition epidemiology and data science program. I put the original definition of the each principles that was developed by Dr. Elena Nomova. And on the right side, I explain how the principles are related to figures in publications specifically. Okay, let's start with the first one, the evidence. So evidence means that all figures should be based on validated data results. So before you start creating any figures, you need to make sure that the data or the results you want to visualize are validated and real and reliable. This is especially crucial in journal publications where the accuracy and the credibility are the key things to consider. And by following this principle, this evidence principle, you can ensure that your figures are trustworthy and can stand up to scrutiny. The second principle is efficiency. Each figure included in your manuscript should serve as a clear purpose in communicating your results. It's not a duplicate things. So if you include redundant or ineffective figures, can result in wasted time during your review, preparation, and publication process. So it's very important to carefully evaluate the value and the necessity of each figure before including it in your manuscript. This can ultimately lead to a more efficient and effective communication of your research papers. The third one is emphasis. The emphasis means that it actually emphasizes the fact that figures should highlight the most important findings of your research and provide a visual aid to help readers to understand and interpret the data. Readers often access figures and images before they're reading the entire paper. If your figures are of a poor quality or fail to effectively communicate the results of your research, readers may lose the interest or be less inclined to read your paper further. Therefore, it's very important to carefully design and create figures that emphasize the key points of your research and make your papers really shine. The last principle is ethics. When it comes to publication, when it comes to publishing figures, it's important to maintain the ethical standards. Journal editors are on the lookout for improper image manipulation and inconsistency between your figures, tables, and other aspects of the data and any other parts of the text of your manuscript as well. If a figure is found to be inconsistent, it may lead to the rejection of your paper and decrease the chance of acceptance, even if it is not intentional. So it's important to maintain the accuracy and the consistency in your figures and to be transparent about any image manipulations. Now that we have the 4E principles in mind, let's move to the practical steps of creating the figures. It's important to note here before we even begin to dive into the steps that creating a data visualizations is not a straightforward task. It requires several preparation steps, and it is a iterative process. And until before your final productions, you will have like many times of revising, editing, and have other people critique it. So here is the overview of the 6 proposed steps. I will be walking through the 6 key steps that will take you from conceptualizing your figures all the way to publishing and store them to a proper platform or database. So first step, conceptualizing. when creating the figures for a paper, it's important to plan ahead and consider how many figures you will need, what types of figure will be the most effective, and what kind of layout should be for each of the figures. So one thing I found it's very useful is to sketch your visuals on paper beforehand. Kind of help you to like the process of sketching in papers help yourself to visualize your idea and to ensure that your figures are effectively communicate your results before even going to the technical coding or like dealing with the software, because everybody can make a very simple ideas or graphically in papers. And in addition, if you have like more complex, so this is another tips. So if you want to create a multi-panel graphs or a very complex graphs, oftentimes we start with smaller pieces, which means you may need to create the graphs into separately and then combine them into a large or multi-panel graphs in any of the software. It's also very important to assess whether you have enough data, you have like accessible variables, appropriate time and location of the data to create your figures. So it's kind of it's kind of relative, or there's actually two separate parts between what you actually have and what you actually want to do. So but it's all helpful when you carefully planning ahead before you even go into the visualization process. So just remember, images should not be an afterthought to your manuscript. They should be carefully considered and planned from the start. Okay, that's the first step about the conceptualizing. So the second one is data preparation. So normally people would think of data preparation as not as a key step or even not a necessary step for data visualization. But from my experience, usually there will be a huge gap between the data you collected or you generated or you received from other people and the data you finally used for your figures. So you will need to tailor your data, modify your data to make it appropriate for the specific figures accordingly. And also keep in mind, if you receive the data from others, make sure you communicate with them and fully understand the structure and the meaning of each variable. Just make sure you're on the same page, fully understand the data so that you can make the correct visualizations. So the data preparation process, you will likely need to perform several data manipulation steps, such as subsetting the data, filtering the columns, deleting the rows. You may also need to change the format, for example, from wide to long, or merge multiple data sets. In addition, some variables may need to be transformed, such as changing from time format or converting them to factors to create a plotting R. So it's essential to be mindful about these data preparation steps to ensure accurate and informative visualizations. Here, I want to introduce a very helpful toolkit in R. Basically, it's a two packages. So this is our cheat sheet for the packaging for the two packages in R called tidyr and dplyr packages. It's a great references for the functions we need to manage our data effectively. For instance, when we using the ggplot function on R, it works best with the data in long format. So if your data is in the wide format where a variable such as year is spread out in rows rather than in columns, you need to reshape them. So in order to reshape them, if we want to convert the data from long to white, you can always like refer to like the cheat sheet to get some helpful functions to help you to do the data management. Another very frequent task is subsetting the data. Most of the times you only need to show the figures for specific like locations and years, or you may only need to have a few variables to plot instead of the entire data set. So here we have functions like subsetting rows, subsetting columns. That helps you to adjust the data set and tailor your data set. So this just are a few examples of how to using these functions and help you to streamline your data management. I personally find this is the major tool I use every day and whenever I need to like manage my data. Yeah, so highly recommended. So the third step is creating figures in software. So I want to emphasize again, so creating a figure is not a one-time process, but an iterative process that requires multiple rounds of discussion and refinement. So don't be discouraged if your initial attempts do not produce a satisfactory results. That happens like 90% of the time when I started to do figures. So be patient and gradually develop your figures by creating a skeleton first and refine the color. So there are a lot of elements you can refine it one by one, such as the color, the transparency, the axis label, title, font, a range of the axis, the directions, the theme, the title, the legend, the text, and more. So first you need to be patient, just let yourself to have enough time and patience to like move on slowly. Every step you do, every time you refine your figure, you find one improvement, that's enough. So also you have to have the ability to pay attention to the details, because that's really helps you to differentiate your figures from others. Another very useful tips is to share your figures with others and gather as much as feedback as possible. So always have a fresh eye. That's very helpful when we all reach to some point where you think there is nothing that I can think of to improve, but they will always have new ideas from other people whenever you give your figures to anyone. So I always suggest to share your figures to people in different domains. They will have different perspectives, and ask them how much they could understand the figures. And also the main idea, is that consistent with the idea that you want to convey versus the information they are understanding. So yeah, so those feedback are hugely helpful and help you to do the further improvement. The last tips is about streamline your coding actually. So if you need to produce similar graphs with a slight variations, you may need to produce the figures in different years or countries where you only need to change that one variable. So you may consider using functions or loops to save the time and effort in terms of coding. All right, so here it comes to step 4. After finalizing your code to produce the figures, the next step is to export your figures from software. Because each journal has different styles and requirements for figures, so it's very important to read the instructions about the format, the labeling, instructions and size of the figures, and adjust your figures accordingly. Here, I also want to because this used to confuse me, so I want to briefly talk about the basic concept of vector and raster. And there are two different ways of storing image data. So vector are digital shapes made of lines and curves that create an image based on a mathematical equation. This format is great for displaying the basic graphs like charts, bar charts, scatter plot, heat map, etc. So keep them in a good resolution. On the other hand, the raster images are made of pixels that can present more details. So the raster image is usually used for photos and paintings, but they can lose the resolution easily compared to the vector format. So here I want to highlight that most of the time we prefer to export visualizations produced in R as a PDF format, which is the vector image. This format ensures that the figures retain high resolution and can be easily adjusted to fit the requirements of the journal. Lastly, there's also some confusion within the ggplot2 packages. That the unit of the size used in different objects are different actually. So in the theme, this is only talking to people who are familiar with the ggplot2. So in the theme statement, the size is defined in the points. We define the text size of so the theme is used to define the text size of the title, the axis, the legend within the theme statement. Whereas in the geom text, this is the function used to define the embedded size and the size of the embedded text. So next slide, I will share some examples. So here we actually use the same code to export two figures. Figure example 1 and example 2. So this is basically two identical plots, but the only difference is that we specify different heights and width for each of the figures. If you open these two figures in full screen, you will notice that the embedded text in example 2 appears much larger than example 1. This is because the actual size of the figure example 2 is smaller, so that it making the text look relatively larger. However, if you compare these two images proportionally, I just resize. I didn't do any modifications on the figure itself. I just make them. I just enlarge this figure a little bit, like the example 1 a little bit. You will find that the text size. So now it is proportionally compared. You will find that the text size is identical in these two figures. So what I want to convey here is that it's important to keep in mind that the size of the figures can affect how the text and other elements are perceived. All right, now we're at the final stage, storing your visualizations. In many cases, journals will request that you share your data, your code, and any supplementary figures. If you directly put those data or code and figures into the supplementary materials, you will get less access to other people, because not everybody will go to your supplemental tables oftentimes. And unfortunately, there is not a platform that is specifically designed to store and share the figures only, but there are some platforms that aim to share any materials related to a journal article. So here I would like to share with you some of these platforms. First, as it's showing here, it's called Figshare. So they claim that they actually create a reference number for you, so that you people can easily find your related data and code as well. So another database is the Harvard Dataverse. It's also a commonly used platform that I would say most people share their research data in these platforms, not so much about the figures. However, you should always check with the journal first to see if they have any specific requirements regarding which platform to use. These are other examples of different open access platform where you can share your data and research results and figures as well. Lastly, for storing your code and data and figures, there is a growing interest of publishing a R Shiny app, which is a web application developed using R, because it has the interactive characteristics. It creates more communication between the authors and readers. For example, it will allow their publication results and to apply to your own data set, etc. So I actually would like you bring you to this web platform. Let me stop sharing my slides and share. So let me refresh it. So this is one of the R Shiny application that mentioned in that manuscript. So basically, they create a calibration equation of the dietary intake. So the ability of this platform is they allow you to upload your own data set and get the calibrated dietary intake. So it's very helpful if you don't have any background in like coding. So they already developed the algorithm for you, and what you only need to do is to upload in the data, and then they will produce those summary statistics for you to compare how the calibrated intake versus the self-reported intakes. And they actually developed this equation in their manuscript, and they were able to demonstrate the real application by using these platforms. So it's a R-related functions, and you will need to know a little bit like web languages and also ggplot as well. This is another example where they produced a algorithm to be able to calculate the subnational nutrient intake distribution. So basically, they have a distribution of a nutrient intake in a lot of selected nutrient and in a lot of countries. So this platform really helps the readers to kind of go through all the results or tables or figures they produced because so it's a integrated platform where they just basically embedded all their results into this platform, because this will be like a lot of pages if you separate them and submit it into like a PDF files. But this website really helps the readers to also explore. You can see they have like, I believe it's 20 to 30 nutrient intake. So you can first explore by nutrient and also explore by countries. So this is kind of like the recent trend, I would say. I noticed in the paper, so whenever they have like a complicated results or a algorithm or like a methodology based paper, they would like to produce a shining up in order to like better present their results. All right. So we still have some time. So lastly, yeah, here is this paper is that what I just mentioned briefly about the producing the distributions for different nutrients and different countries. They published very recently. So we still have a little bit time, so I want also walk you through one figure example on this paper, and just talk through my entire process for producing this figure specifically. So this is a multi-panel figures, which visualized the rate of, I believe it's salmonella, the rate of salmonella across different months, across different years. So from 1996 to 2017, and with a monthly rate data. So because it's a multi-panel graph, so basically when I made these figures in R, I start piece by piece. So first I create a box plot with monthly rates for each month of the year. So this is the average across all the years. So because it's a box plot, I could see whether they have some outliers in each of the months in certain years. And then this main portion is the heat map, shows the distribution of the monthly rates for each year, where the darker blue hues indicate a greater rates. And the rotated bar graph is the yearly rates. So basically it's a sum. It's a sum of this heat map together, and the color just indicating the years. Finally, so lastly, I will share you the actual code that I actually produced in R. Let me share my screen. So this is actually the entire code for all the figures in that paper. But so you will see if you have a decent amount of figures, how many lines of code you will be producing. And also make sure you always have a good annotation, so that you can understand like after a certain amount of time, and other people could also read your code as well. So let's go to the heat map. I used it's figure 3, sorry. Yeah. So the figure 3, I actually use a function in R. So if you haven't used a function in R, basically it give you like you have the option to create a general variable where you can change accordingly. For example, I use a generator rate var where I can replace any of the place where I set rate var to a different variables so that the function can produce different figures for different variables. So this is the data that I actually have. So basically, I want to produce a heat map for each of the column. So that function helped me to run over all the columns that I want to produce. So here is a data management steps where I only need 3 columns to produce these figures: the year, the month, and specific rate for let's take a look one more time. Specific rate for certain diseases or pathogens in different, either in the United States or specific states in the United States. This is the code for importing some PNG files I imported externally from other resources. That's not the main piece. So this is where I produce the heat map. So you can see you really need a lot of lines in order to really refine each of the pieces. Like I said, like title, the colors, and appropriate legend places as well. I use a function, but I want to have the y-axis for the box plot adjusted accordingly. So you can ignore this part as well. And this is the bar chart. So what I want to show here is that so when you have like complex figures, you always do it piece by piece. So basically I need to create a heat map, a box plot, and the bar charts. And then finally, this is the code for the box plot. And finally, I use the GG arrange, which I combine all the figures together. And that concludes the function of this. That concludes the function of producing these figures. If I create this function successfully, here is the specific use of some function. I can specify the name of the variables, and they can produce me any of the any of the figures in any of the location and the pathogens. So it's very convenient, but only if you produce like a large amount of figures. And you can even write a loop to produce all the figures at a time and save it automatically. So I didn't dive into detail how exactly they should be doing, but just give you some ideas. You can use functions and loops in order to create some replicated figure, iterative figures over different variables. So these codes are all public available online. So we don't have much time to go over into the details, but I'm happy to discuss with you if you have any questions for the workshop. Yeah, that's it for the entire workshop. Thank you all for listening.